Good morning or afternoon, wherever you may be watching this live presentation from. I'm Scott Boutler from the Viessmann Academy here in Langley, British Columbia, and just happy to welcome you to today's second helping of our presentation called Setting Up the Cascade Control System or Connections and Startup Programming, whichever one you prefer. The presentation is going to be the same today. I'm happy to mention as well that joining me from our academy out of Waterloo, Ontario is our academy instructor and all-around awesome guy, Mark Norris. Good morning, Mark.
Good morning, Scott. How are you?
I'm doing well. It's always happy to hear that you actually can hear me when I say good morning to you, even though it's afternoon where you're at. But
That's
how
why
are
I'm
things
here.
going?
That's why I'm here, just to make sure that I can hear you.
I appreciate that. So
So,
I almost bit my tongue there when we signed off. I was just having a little snack, getting ready to go here, and so I'm suffering with a little injury here right now, but I think I'll work it through.
you better suck it up, buddy, because your presentation.
I'm gonna give her a go here.
There's no downtime for injuries. You have to.
That's right, exactly, man. We just work through it, right? So
Yeah.
I might kind of have a little bit of a lisp today, but you should be able to understand me okay out there.
We'll figure it out.
Yeah. So what's going
Welcome,
on in
everybody.
Waterloo today?
It's kind of getting warmer outside. Like the snow's melting off my car, so
That's good. You can
we've
see
had
your
a
car
whole
at
crap
least.
of snow in the last little while. So hopefully it starts to go away.
We're around the corner, I think, on winter here as we get through as we stumble through February into March here, and like I
Right at the end
say,
of the tunnel now. So
that's good. That's always good, man.
that's how I make my way through winter, right? And I look at December the 22nd or 21st, shortest day of the year, and I go every day after that's a little bit longer. We're closer to spring.
Exactly, just a little bit more daylight. Although here on the West Coast, it's sometimes with the cloud cover, it's hard to tell if we're actually getting that extra minute of light during the evening or not. But yeah,
Welcome, everybody. We have an ability for you guys to ask questions as we go along. So you'll find a Q&A box somewhere in your toolbar, and please use that for questions. Don't use the chat for questions because the chat doesn't record very well and doesn't keep a track record of it very well. But if you ask in the Q&A, I will try to keep up with the answers in real time, and if we can't, we'll talk to them at the end. But you will get a copy of the Q&A with the email out of the presentation later on. So this is why we want to get it in the Q&A. So anybody who asks a question, you'll get the question and the answer in a document. So again, you're going to get a video, or a copy of the slide deck as well. And the video of this will be recorded and put up online. It usually takes me about a week to do that. So in about a week or so, you'll see it, this webinar online. So I'll give it back to you, Scott.
thanks, Mark. So like I say, we'll be grabbing your questions as they occur there. We should have some time at the end. This has been kind of revised. I think Miranda had a look at last time we did this presentation and added a little extra time for us. So we do have about a 90-minute window here. We should be finishing up a little bit before that, I think. So if you can't stay for the whole time, you've got some questions, we'll still get those answers as Mark had mentioned to you. We try to do as much as we possibly can. This will be archived after the fact as well. So moving forward, it'll be available for anybody that needs it. So if you are, a wholesaler right now taking this in, and you've got some guys that are, dealing with these types of controls in their facilities, whether they're starting them up or they're doing the service work on them, they're responsible for programming, whatever it might be. I think it's going to be a handy presentation for people, both past and present. There's my lisp there, past and present cascades we're going to try to review here. So I really targeted just the simple setup of these controls, and I'm going to mention throughout this, if you want to go to a deeper dive of some of the information I'm showing here, we have archive presentations already that have been done. For instance, just on the start off here, back in September, Mark did a presentation, which a lot of the slides I actually borrowed from Mark here. Thank you very much, Mark, to put this presentation together. But he goes into a much deeper dive on some of the strategies and some of the theories of the who, what, where, and why these cascades work, along with some of the wiring connections as well in his presentation there. So if you are really looking for more information about that, then you can go back to these archives and review those as well if something kind of strikes you here. But we're going to be moving on into the presentation here. So the idea is, regardless of the type of boiler, there is a commonality when we look in these multiple boiler room sites that we have Viessmann boilers sitting in. So whether it's 2 boilers or 8 boilers or somewhere in between there, whether they're condensing, non-condensing, they all have something in common. And if you're following the presentation up to this point, that is the cascade control that we're talking about. So all those boiler rooms we just had a look at all have a main control, and of course the boilers are working off of that particular main control. We're going to get a little bit deeper into the relationship here as we move through, but today we're going to stick to the Veto Control S. And if you look at the controls that don't have the little X across them there or emitted, those are the controls we're going to focus in on today. They're all called Veto Control S. They're off-the-shelf type of controls, which means that we don't have to make those specific to your job requirements. These are the -S at the end of the Veto Control means it's a standard type of cascade, and of course this allows us basically to do multiple applications without configuring custom type of controls for your building sites. Some of the connections that we talk about here are relevant to some of the custom panels, but I can't say they'll be for all custom panels. So I'm just going to kind of omit the Veto Control Cs from this particular presentation, because some of them do have some different style cascades that this wouldn't really be relevant as far as information. So what type of control are you working with? That's a very good piece of information whenever you're dealing with things like, if you're trying to order parts or if you're looking for tech support, any type of information. You want some manuals for your controls so you can kind of read up on them. All of the controls in the Cascade family that we see here, both past ones like this guy up in the top left here with the white interface. We've got the bottom left one here with the menu keys and the buttons on the right hand side. And then we went into touchscreen as we went through the generations here. All of those controls will give you a model number in the bottom right hand corner of the control. So if you're looking for information and finding what control am I dealing with here, so I can grab a wiring schematic, for instance, which we're going to talk about a little bit later on, you can look at that bottom right hand corner and get that information on what type of Veto Control, Vetrotronic 300K, which is a Cascade type of control, what model number that is. And then from there, you can find that information on our website, or if you're talking to the guys at tech support, that information is critical for them to help you with any type of questions you might have on those particular controls. Reality is all of your boiler controls, even if you look at the bottom right hand side, will tell you what that boiler control is. So just a little bit of extra information there. If you're struggling with your identifying what type of controls are in your boiler rooms, if you've got the little orange boxes on the side of the boilers or on the front of the boilers, if you look at that bottom right hand corner, you'll be able to identify what that control is right in that particular spot. So there are multiple controls, as you just saw there, but there's also different cascades for different types of boilers. So some non-condensing, condensing boilers, some of them have premix burners, some of them have diffusion style burners on them. They do have different types of controls, and of course different generation boilers that have different cascades in here. We're going to basically walk through all of these controls and have a look at them and basically their relationships and a lot of the similarities that they have as we move through. As we've gotten into developed more boilers, the control cascade is now integrated into the boiler controls as well. So there are some out there where you won't have a control sitting on the wall somewhere like you see on the top three. You're going to actually have that control sitting right on top of the boiler, and one of them will be designated as a cascade. Well, the other boiler control here would be a lag boiler control, for instance. And with the CA3 boilers, which we're kind of depicting here, you would have one main cascade control that operates one of those burners, and then you'd have two other controls that would be what we call lag controls on those units. So different controls as we went through the generations, but also we've also moved into integrating those controls onto some boilers as we've developed new products the last couple of years. The cascade itself, as far as that relationship, so just talked about why these cascades are here, and I'm not going to get into the deep dive. It's more about the connections that we're talking about when I look at this, but it is capable as a control to be a standalone type of control. It doesn't really require another control to manage it. It's going to manage your building's heating system requirements. You look at this display here, we've got multiple temperatures that we're working with here. We might have some auxiliary loads that we're going to talk about. You've got domestic hot water, you've got recirc capabilities. Let's kind of look through all this. So out of the box, the control is capable of utilizing single or multiple temperatures if you add some components onto it for your heating system. And we're going to operate that off of an outdoor reset strategy. So the control itself out of the box is going to have an outdoor sensor that you can connect to it. And the outdoor sensor feeds the temperature outside currently. And we're going to add basically program into all these cascades. If we're using the outdoor sensor here, we're going to add heating curves requirements for all of the circuits that we're going to look at here. So we'll have a peek at that. There's a sensor that's going to be connected to the cascade as well. And this sensor here is where we're going to be looking for temperature. Some controls you'll see are primary, secondary. So we look at the control over here, that sensor sitting in the header as with the previous schematic looks. It's not necessary to have primary, secondary with a cascade control. It just depends on the boiler more than the cascade. We tend to cascade low mass boilers and not cascade high mass boilers, but it's optional. It depends on what the system is and what the requirements are. So multiple boilers here. We have this guy up here where primary, secondary, where that sensor is going to be placed usually in that primary, secondary header here. We've also got down here in the bottom right a CA3B where we've got what we call here as a common supply sensor. Which means that the piping that the sensor is placed in will pick up the temperature of any one of the three boilers or three burners as they're in operation. And that's important for these controls up here too. When you have separate boilers, the placement of that sensor has to be where it's going to pick up the temperature, supply temperature off of any one of these boilers when they fire. So we're going to make sure that that placement, that sensor is going to pick up what we call a common supply area. So that common piping is important for proper operation of these cascade controls. So where that placement is critical for your operation. So going back to the main schematic here, there's that sensor in a primary, secondary system, usually placed in that header. When we have multiple temperatures, as I mentioned here, Viessmann have mixing valve extension kits that are available. So we can operate up to 3 different outdoor reset heating curves on one single cascade. So if you have multiple temperature requirements in your system, you add a Viessmann mixing valve and that's we're going to wire up the pumps. They're going to come right off of the boiler cascade control here. So whether it's a standalone pump we have here, which we call an HC1 or heating circuit A, there's no mixing valve on that one. That's basically right out of the box. Every cascade can do that one. We can add 24 or 120 volt floating mixing valves to our controls here. So it's either or here, or you can have both. You can have one 120 volt mixing valve and one 24 volt mixing valve if you want on these systems. All the pumps are going to wire back to specific terminals on the cascade. Those mixing valves, we also have the floating signal for those. So they're both power open and power closed. So not just a 3-wire, you typically 4-wire to these mixing valves to make sure we power them open and power them closed as we're in operation. And the sensors. So the sensors as well, as you plug sensors into a cascade control, it opens up that those must be extra heating circuits you're working with. And now they'll give you the option of programming all those extra heating curves and timer programs, whatever you're looking for. So right out of the box, we can basically have one heating curve. We add one mixing valve. We have a second heating curve and second set of heating circuit values that we can program. And if we add a second mixing valve, we got a third temperature now for a heating system, a third heating curve, and of course, all of the other programming requirements for the heating circuit to make it operate automatically for you. So those are available. Auxiliary loads are capable as well. So you could have 3 temperatures for, heating. This could be a heating, another heating loop if you want as well. It doesn't necessarily have to be, auxiliary load like a pool or car wash or some sort of food processing application. But typically it'll work off of something other than outdoor reset. It would be, it might be like a dry contact, for instance. We need a fixed temperature going out to whatever this load is. We just close the contact. And the control here is going to send a fixed temperature requirement to this particular location. And now we're going to operate this auxiliary load based on just a dry potential free contact going to the control or cascade. The other option is to use a floating, and you can do both of these either or, a 0 to 10 volt analog signal. So we can float that set point instead of just a fixed temperature. So depending on what your requirements are here, you could do one or the other, or you could have two loads here and operate one off of just a dry contact and a second one off of a floating signal as well. So it gives you lots of expandability if you know what you can do with these controls. The other ability of the control out of the box, and it's going to come with a sensor for it, will be domestic hot water operation. So we were going to plug another sensor back to the control here. It usually goes into the tank for your indirect storage tank here, and we can program a set point for that temperature in that particular tank. And we can also create a priority for that load. So we got the pump down here. So whenever a sensor is connected, we are going to control that pump for that domestic down here as well. And we are capable of allowing all of the boiler capability here, all this horsepower, all the BTUs, kilowatts, whatever you want to use here for a unit. We can direct all that energy into the tank if we want to by ensuring that all of the other loads here are shut off whenever the domestic calls. If you have Viessmann mixing valves connected to your Cascade, we can also use what we call load priority. So if the day, if the tank's being heated up appropriately here, we're not going to basically lose that capability of keeping the domestic hot water heated. We're not going to have a shortfall on that side. It might start to open up the mixing valves here, turn these pumps on, and basically allow the building to still be heated while we're simultaneously heating the domestic hot water without any sacrifice to the performance of that domestic hot water tank. If it starts to become an issue, it will basically start closing the mixing valves back off here again and delivering that energy back to the indirect tank. So it gives you some flexibility there and some big buildings where that could be a problem if we had priority for domestic hot water all the time without and blocking the space heating to that particular building. So that's something to consider as well on your systems. And we can also wire the domestic hot water recirc pump off of a Cascade control as well. So it gives you a complete system control here when we look at this particular schematic. And that recirc pump now, rather than being running 24/7, you can put on a timer program, a bunch of different options depending on the Cascade control you're working with from past to present. But it opens up more programmability and a more efficient system if we put that recirc pump on some sort of time program where it's not running 24/7 in your system. Of course, that's going to create more load for the tank, more cycles of your boilers to feed that domestic hot water, and of course, a little less efficiency, more gas consumption for your system. If we put that domestic hot water recirc pump on a timer, we're going to save a little bit of energy by doing that. But the key obviously is that comfort is king. We don't want to inhibit that. So like I say, it's based on the system, what type of time program we can initiate for that recirc pump. We also have another option here, which would be instead of a standalone Cascade control, which is quite common here in North America, we would have a building management system that we're connecting to. So it's a full integration of our control system with your BMS control. Regardless of the control platform they're using from the outside world, we go through their main control and then through a gateway. So there's some older gateways and some of the newer gateways you see in the pictures here. Those gateways are connected to the Cascade control. We'll look at how that's all done. And they are capable of writing a set point through the gateway and basically controlling the heating system here. So what they're controlling here now and what we're controlling with the Cascade is very different. So they're controlling the heating system. So you see the outline here in green. They're controlling domestic hot water through the BMS. They're controlling all of the mixing valves, the pumps, all of that stuff is now controlled off of a third-party control. What they're sending, what we're doing, what our responsibility here as a boiler manufacturer, control manufacturer is we're looking after the boiler set points. So when we get a temperature from the Cascade or from the building management system, the Cascade is going to make sure that we reach the set point that they're looking for. And The importance of that obviously is that if we've got a BMS system connected into our integrated into this whole, and we're integrating our Cascade into that whole system, we want to make sure those sensors that the Cascade, as we just looked at, has a sensor that's going to be used, a common supply sensor. Of course, the building management system is also going to have a sensor there to pick up the temperature that it's desiring. We want to make sure they're in a close proximity to each other. That way, there's no lag between the sensors where the BMS is showing that, you know, we're not quite making temperature or overheating because we are at basically at different locations in that common piping. So important to kind of have a look to make sure those sensors are fairly closely connected together. The other option would be instead of just writing a set point here, which can be an issue sometimes depending on how busy the bus system is in that building management system, how quickly that set point is adjusted. Another way of doing it, and which is quite popular, and one I see probably the most at least in this side of of North America, is using a 0 to 10 volt floating signal. So they'll monitor the system, and when they want to adjust the set point, they'll adjust a DC voltage signal to the Cascade control. So that would require an accessory 0 to 10 volt modules we're going to look at here, how they're connected. And they can now float a set point and a little quicker connection because that's directly to the Cascade through the accessory here. And then we have the ability also of just a dry contact. So just like we looked at earlier there, they can also just close a contact on the Cascade, and now they can just use the system as a fixed set point. So when they need heat, they just close the contact, boilers fire up from the Cascade's demand signal, and they fire to that particular set point, whatever that might be. So let's have a look at how that all operates. So regardless of what's going on here, when a Cascade gets a call for heat, so whether it's 0 to 10 as we just looked at, or a close contact, it's going to look at what the highest temperature requirement is in that system currently on. And it sees here that based on all of the demand signals we have currently, 135 Fahrenheit is the temperature that is the highest of all three. That's the target for the Cascade, and the other systems are going to operate based off of that 135. So the mixing valves will mix down to 90 and 100. We'll get a little higher temperature on the HC1 circuit because it has no mixing valve on it. And the Cascade is going to want to see that temperature, 135, at this sensor. So it knows it's succeeded in reaching its temperature when it sees it here going out to the system. So common supply on a primary secondary would be right at this particular point, the common supply temperature to all of your circuits off of that secondary system. And the Cascade is going to send that set point to the boilers here, and that set point and how it stages the boilers will be directly related to how you program the Cascades. There's different strategies for how the system is going to operate. So it's going to start bringing the boilers on, and depending on, you know, if you've used condensing or non-condensing, the boilers may kind of modulate to a point, and then another boiler is going to come on. Whereas in other applications, through the communication here, you see in the blue, it will turn one boiler on. It has to go up to 100% before another boiler goes on. There is some strategies here, as I mentioned, that the control is going to work on. But it wants to reach that set point, and it's going to turn the boilers on until it gets to a point basically where that is now a manageable set point. It doesn't want to overshoot. There are some adjustments to differentials and stuff like that for your system. So you might have the system set up where it can overshoot a little bit here. But what it's going to do is, based on the information you programmed, it wants to manage the system so it doesn't overshoot or undershoot the system here. It wants to basically operate based on your requirements, and it's going to start to shut those boilers off as it gets closer and closer to that number. And eventually, of course, we shut that boiler off once we meet the complete set point here as far as operation. The Cascade can also rotate these boilers automatically. You have a manual rotation on the Cascade where you can walk in as a building operator, for instance, and you can, you know, go in every week and if you want, and just basically rotate from lead lag boilers if you wish. You can also have it programmed where it just does it looking at, you know, once a month, for instance, or based on a number of run hours, and it will start to rotate those boilers. So, if we program for, 1 day in every month that looks at the run times of the boilers, is one of the options. It's going to look at this, and based on the number of hours that are the least, that boiler is now the new lead for this next month that we're going to have. That's the system's going to be in operation. And the one with the most hours will now be the last boiler. So basically, the whole idea here is to get equal wear and tear on your heating system, and we can do that automatically through the Cascade control. The Cascade also has the ability, whether it's standalone, to communicate faults in the boiler room or through a BMS system. You can also be able to see those faults on your BMS control as well. If there's some issue here where a boiler, for some reason, fails to respond or has some sort of a fault on it, that's going to be communicated back to the Cascade control. And if we have operation of that boiler number 3 and it's been interrupted for some reason, the Cascade will immediately switch another boiler on here now. So it's basically going to make up that shortfall in BTUs by turning another unit on here, and you will get a fault on the Cascade as well as that individual boiler. The Cascade is what we call a fault manager, which means anything in the system here that faults out, whether it's a sensor connected to the Cascade or one of the boilers connected to the Cascade fails to communicate or communicates back that it's in a fault and locked out, you're going to get some sort of indication on the Cascade as well that there's an issue in the boiler room, and that's transmitted through any type of building management system as well to let people know on the other side that there's an issue in the boiler room that needs to be addressed. So the whole idea here is that anything happens in the boiler room that requires some attention, the Cascade wants to communicate that to the outside world to make sure that something's being addressed here before that becomes too big of a problem. As far as the boilers go in this system, really nothing changes as far as the boiler operation. So whenever a boiler operates, it has a set point in mind, whether that's in a standalone system or if we're in a Cascade, it's going to get that set point. The boiler will still look after its own internal logic, which means as far as any external safeties connected to that boiler, any type of combustion management system that's connected to the boiler, all those are still primary. So it's still that's still going to be proprietary, which means that there's an issue there, that burner is not going to fire. So if we have a low water cutoff connected and we're in a low water condition, the Cascade can't override that and say fire. It's part of the logic of the burner to say, no, that's unsafe, I'm not going to fire up. It's still in its own capability when we're operating the system as we just described. It's going to modulate to its own capability, which means that it's not going to, the Cascade has no ability basically of ramping that modulation up. That's all internal on the boiler control itself, the logic. So it basically doesn't want to cycle. There's an anti-cycle feature in the logic of the burner. And it's going to reach that set point based on the load that it sees off of its own boiler sensor internally. And if there's anything going on as far as a problem in the system, again, whether it's combustion issues or some sort of a safety, it's going to basically, it won't allow that boiler to operate outside of its own design parameters. So again, something like a limit on temperature. If a boiler can't reach, low mass boilers, for instance, if you give it a 95 degrees C set point, some of these boilers are not going to give you 95 C. They're going to basically give you a maximum about 80, 82 C. So that control is not going to override to 95 on these boilers. It's going to basically still maintain that limit of 82 C. So we'll look at that here as we keep going. There is the ability as well to have each boiler also connected to its own individual alarm, as I mentioned. So when that boiler alarm's off, you can basically see that alarm for each individual boiler as well, not just the Cascade. So all that stuff, as far as the boiler goes, still manages internally. It's just getting the set point now from the Cascade instead of in its standalone capabilities, where it would basically have its own logic in that particular reference. So as far as displays go, so we're going to have a little review of the displays. This is kind of neat because it goes down through the generations of our controls. This is a little bit of a boring looking picture screen here, no color, black and white, but we'll kind of move through the generations here. So this is one of the first generations of the Viessmann platform, we call it. And you see all of the different buttons here. So each button had a specific purpose. Anything with a clock on it was usually time program type of things. You got slope and shift here on your controls. Anything with thermometer would be temperature based. So we're adjusting temperatures for like domestic, for instance, or for night setback on timer programs here. And you had some of the functions here of navigation through the control. We went to more of less buttons and more text-based on the next generation of Cascades. And then we've gone to full-on touchscreen and a lot more information on the screens as we move through. So I think we've done a large improvement of these Cascades as we move through. But there really is, just kind of the idea here is we've really communicated a lot of information very similarly throughout the generations of these particular controls. So the first generation here, you have basically on the screen here, these dashes were fairly important to tell you what was going on with the boilers itself. Boiler sequence obviously is in 1, 2 here. So boiler 1 is the lead. Number 2 is a lag boiler in this particular Cascade. The sequence here also tells you, so if you saw a number that was ahead of both of the dashes here, that told you that that boiler was actually running. So if we went over to boiler number 2, that one there should be firing or in the process of firing at that particular point. Anything basically sitting between the 2 dashes on these particular generation of Cascades was a boiler that was waiting. So it was available, communicating back to the Cascade that I'm available to run. I'm just waiting for you to give me a set point. So it's sitting there in a kind of holding pattern, waiting to get a set point from the Cascade, but it's not firing currently. And anything that was behind the 2 dashes, as we see here, that particular boiler would be offline. So whether that boiler was just turned off and not communicating anymore, or if it had a fault, if that boiler had a fault on it, then of course we would also see the fault on the Cascade as well. So it doesn't necessarily mean that that boiler is in a fault mode if you see it behind the 2 dashes. If you're servicing a boiler, for instance, you might look at the Cascade and see that that's behind the 2 dashes because you've got it off and you're doing the service on it. If you do see a fault on the control, obviously, then we've got some other issue that we got to adjust there. You'd also see the day of the week, basically just 2 digits here. So MO for Monday, TU for Tuesday, so on and so forth. And your extended menu here, as I mentioned earlier, was all of these buttons and specific functions for timers, adjustments of temperature, your slope and shift, your time and your date were sitting right here on the screen. We've got this little card that is actually available as well. And through these buttons, you can also push multiple buttons together here and hold them down. And you get into the areas like coding level 1, for instance, by holding the standby and the tap button, or coding 2, you would adjust or basically press the tap and the faucet button together here and hold those down for a few seconds. You get into coding level 2, relay test, so fault history. There's a bunch of different options here. As you basically hold the buttons down, you get into other areas of the control. And this is available if you wanted to in a little card form. You can laminate. We've had guys that print these off and laminate them, and they'll stick them on the boilers or whatever so that they can have that quick reference later on. The second generation of the Viessmann Cascade looked more, like what we see here. A little bit more information was added to the control as well. A little less, buttons. So less buttons you have to memorize what those symbols all meant. More text-based. But we also had, kind of carrying on here with, boiler sequencing. So you see 3, 2, 4, 1 is a boiler sequence. So boiler 3 will be the lead. Boiler 1 is going to be the lag boiler here. Boiler status is a little bit basically the status would, if the boiler was on, that little rectangle below the boiler number would be very highlighted, so it would lighten right up. So that boiler number 3 is on right now. A little bit darker, a little less highlighted, 2 and 4. Those are boilers that are waiting. They're in standby and ready to fire if the Cascade needs them. And of course, boiler number 1 here that's X'd out is not available. So whether that's a fault or just it's been turned off, then you'll see that little symbol there. You also had the common supply temperature, so that common sensor, that's a common supply sensor, whether it's in the low loss header or somewhere in the common piping, you pick up a temperature, what that was seeing right there. If there's a fault on the control would fault out as well. And your extended menu here was the 3 lines and the 3 dots now to get you into different areas of programming of the control, coding levels, all that kind of fun stuff that we do when we set up the controls here. when we move to the touch screen, so now instead of buttons, the screen itself are the buttons here now. So more like your cell phones, etc. We've got same sort of idea. You got the boiler sequencing here. So this one is just started up, and 1, 2, 3, 4, 5 are all in sequence. What boilers are running? You see the little circle down below here is highlighted. If the boilers are running, if they're not available, if they're in standby, that that little circle is not highlighted, it's darkened out. If they're not available through fault or just through turned off for boilers in standby here, then you see the X out as well on the circle below. Now you get a little bit more information here. You'll see the common supply temperature. So whether it's in the low loss header or on the common piping here, you also see the set point that Cascade is now trying to achieve. So whether that's through the BMS from 0 to 10 or a dry contact fixed set point, or if it's a standalone Cascade that's operating off of an outdoor reset function on a heating circuit, you'll see the set point right there that it's trying to achieve. Our kilowatt input and outputs are also, oh, sorry, I backed up here a little bit. So we've got the kilowatt input or MBH, depending on the units that you're looking at, also displayed now. So something more interesting as far as what those boilers are basically, what the output of the boilers are at that current state. A little indication in the window here of the modulation percentage. You can see this in another area in actual percentage, but here's a good indication. This boiler here is just about at 100%. Or boiler number 2 here looks like that's at about somewhere around 25% output, so probably in low fire, what have you. So we get some little indication of that. Time and date here now, in your day, month, and year, and of course in a 24-hour clock here as far as the time goes. And fault output, you see a little triangle on the control here to let you know it's a fault. You just push that little triangle and it tells you what the fault is. And of course, your extended menu button is now at the top. Push this button, and now you're going to get into all the different programming functions of the control. We're going to be using this here as we move through the controls. And last but not least, this is the most current Cascade that we have. And this you could see as an external Cascade, one that's hanging on a wall, the operating boilers, or it could be basically an integrated Cascade, say in a CM2 or a CA3 type of boiler. You'd have this type of control on it. And a lot more indication here and more color, more technicolor here that we're looking at as far as what those boilers are doing. So whether they're on, you see the little highlighted flame, and of course the modulation percentage here in blocks now. Whether it's off, but operating normally, that's basically grayed out, it's not highlighted. If it's offline because the boiler has been turned off or it's been put into frost protection, then you'll see the little X out here. If it's off because it's in fault, then of course that little boiler symbol is going to be red, highlighting that there's a problem with boiler number 1 that we're looking at. Your sequence is at the top, so still 1, 2, 3 on this control. Those will rotate if you put them into automatic rotation. The temperature here now, again, we see the actual temperature and of course the set point that we're looking for. Our output here, input of the boilers in kilowatts or in BTUs, again, depending on what you've got. Time and date up in the corner. Your fault in the very similar area to the previous Cascade. And of course, there's extended menu in the same area as well in the top right-hand corner. So a lot is similar to the previous Cascade, and then a more modern. It's just the display has been upgraded a little bit to be a little more, a little bit nicer, a little bit more user-friendly. In my opinion, the color really makes a difference to what you see in that control. It really stands out, I think. The Cascade connections. So this is kind of what we're getting into. So just strictly connections, how we wire these controls. The whole idea here is that we're going to operate a system. So not just, multiple boilers in a system that aren't communicating with each other. When we add a Cascade to the system, the whole idea here is that everything works as a team. And if one of those boilers is not connected to the team, then of course it's not part of the team. So the whole idea is that we integrate all these together, and there are methods for us to make sure that those connections are correct. We're going to go through some of that as we move through here. We would use on all of our Cascades and all of our boilers LAN modules. So as far as communication between the boilers and the Cascade, we will use LAN. We have the LAN echelon chip in these communication cards you see on the left-hand side. and they are all basically available for all of the boilers and cascades. The Viessmann 200 is a special little boiler in that it also has the ability of using Viessmann, more proprietary communication between the boilers and the cascade, which we call KMK. So we have a KM bus communication capability. It's a little pink plug that basically Viessmann accessories can talk to Viessmann boilers and Viessmann controls. So the little Viessmann boiler is unique in that it has an option of using KMK between the boilers and the cascades. But as far as any communication between the cascade and the outside world, it's always going to be via, at least on the standard cascades, it's going to be via LAN communication to those gateways that are out there. So we don't use KMK between the cascade and the gateways. It's always going to be a LAN card in the cascade control, and then moving over to the LAN connection on the gateway. We'll look at that here as well, but this is strictly the KMKs between Viessmann's 200 boilers and the specific cascade that's used for the Viessmann's boiler controls. So how many LAN modules do we need? It's basically you need one LAN module for your cascade, and you're going to need one LAN module for each boiler that's part of that particular system. So you just add those up. Some of them are already included. So the CA3, for instance, has already been wired for communication between the burners, pressure vessels in that boiler. So whether it's 2 or 3 burners or controls you have in those, they're already pre-wired with LAN. So you don't really have to order those modules. It's already done for you. Whereas if you're doing separate boilers, you're going to have to add those modules to those particular units and possibly a LAN module as well, depending on the particular control that we've got going on. Where do we place those? So that's one of the questions that always comes up. You get these little boxes on site, you open them up, and of course, where are they going? Or if you've got a system that's already installed, you want to know where those modules are located. I've got the KMK module actually shown here because it's got wire connections here instead of the RJ45 connection, but it's in the exact same spot. So regardless of the newer style Viessmann 200 or the previous generation WB2B, the communication module was always connected into the left-hand side of that controller. There's a little cavity in there and a special little plug and adapter that we would plug that communication card in here, and then we would wire that back to other boilers or to the cascade. We'll see how that works here in a moment. With the CU3A, so the Viessmann 300 boiler that goes up to about 200,000 BTU high mass boiler, so it's a residential or commercial boiler, depending on what your application is. The control is at the top of the boiler. You got to take off a couple panels, and that LAN module, and it's only LAN with the CU3A. It's not there's no KMK capability for that communication. It's going to be a LAN module here. It's plugged in on the left-hand side. So this control is actually control console is actually really pretty much the same as what you see on the Viessmann. It's just placed in a different area here. So it's placed on the top here versus on the face of the boiler like you have on the Viessmann. And there's that module plugged in. On the cascade control, so it doesn't matter which generation cascade you're looking at here, or if it's on a CA3 boiler, like you see down here in the bottom left-hand side, that LAN card is always standing up vertical. It's the only card I think in the controls actually stands up vertically inside, and the connections are on the bottom. So it looks exactly like this. It's plugged in a little bit to the left biased of the control, but plugged in there. And of course, you put your Ethernet connections in the bottom here. And so it doesn't matter what control. And again, this is how a typical system looks. The reality is the LAN cards typically have 2 connections, 2 ports. They are not polarity sensitive. It doesn't matter which way you go in or out of those controls. It doesn't even really matter how you plug these in. You could go from, different reference points here. You don't have to go in and start at boiler number 1 as we see here. You could plug in the cascade to boiler number 8, or it could be right in the middle of the boilers if you want. It just depends on how you order the connections here, what makes sense. As long as all of the devices are connected together here, as we see in these pictures, doesn't matter which ones we're looking at here. We got 3 different types of boilers, 3 different types of cascades, but the connections here are always the same. Everything is joined together as a team, as basically everybody's networking together here on our little LAN network. There are no open ports, though. One thing to remember, your controls will typically come out of the box with some end-of-line resistors, these EELs. and they'll close off any open ports on those lawn modules. And that just ensures that there's no issue with any type of echoing or anything where the control may think there's something past that point. This kind of closes the door as far as the communication. So it just essentially closes that network on both sides. When we plug the connections in, so this is a basically a Cascade here on the left-hand side and two standard boiler controls. And again, this doesn't matter if these were white control interfaces, black control, touchscreen, regardless of the generation you're dealing with here, all the same function here. You see the lawn cards and each one of these controls plugged in, virtually the same spot. When we plug the devices in here, what you get is what we see are boiler control here plugged into the Ethernet card over to the lawn. And 1 second here. And then from this control here over to the boiler. Now we have to put those end of line resistors in. And of course, they're plugged into the open ports here. So that's where those would go. There's no basically open lawn ports on the bottom here now. And I always like to push those lawn cards in after you finish plugging those Ethernet cables in your RJ45 connections. Just give them a little love tap. Just plug them in, snug them in there to make sure that they haven't kind of got out of kind of got out of the socket there a little bit. Plug them in, and of course you'll see that when you get these things up and running, you've got the little green light flashing, and that's always a good sign that we've got our communication is activated between all the devices here working together. We do have a way of essentially plugging in our, participant check here to make sure all those connections are done correctly. Our lawn cards are plugged in okay. And of course, all of the Cat5 connections are done correctly if they were done on site. You see that my model's hands here, the fingers are on the OK button on the white control here, OK, and the faucet button here. Hold those two down for a few seconds, and you'll get into what we call a participant check. It's also called a subscriber check in some of the controls. Depends on what generation you're looking at here. When we perform this, basically what we're doing is we're going to check that connection between the boiler and the Cascade. You'll see the control here as we went through. You see it's flashing, it's winking at us, I guess. And some of the newer controls actually does show a wink on the screen here when we're doing this. And this just shows, you'll see check OK here, that participant number 2, boiler number 2 is communicating back to the Cascade. We know that that lawn card is connected correctly. It's communicating. And of course, the Cat5 was wired correctly and everything's good to go. If we do that check and we get a check not okay here, there could be some issue with that control. So maybe it's a lawn card problem. Maybe it's the Ethernet cable. We got to check that out. Maybe there's a fault on the boiler. As we see in this particular case, we've got a 38 fault in this boiler, a little red light on it. And of course, that boiler would now be stacked in the back of the dashes here with the fault output indicated on the Cascade control. So it's a good way of checking to make sure that your connections are done correctly. And the same with the modern control. So going right to this control here, we can do the same participant check. If we basically hit the extended menu here, once we push the extended menu, you'll get to the main menu. You push the little arrow key here, and that's going to get you into the service. You connect, you basically push on the service icon, and it's going to ask you for a password. Some of the touchscreen controls, it's VI service. The newer control, it's VI expert to get you into all the levels. And from there, you can go into service functions down here, and then we got our lawn subscriber, lawn participant check right here, and that would do the exact same function we just looked at on the older generation of devices there. So a couple of examples of some of the different setups here as we looked at. So in a CU3A Cascade system, that Cascade control can operate up to 8 boilers. And we see all those connections done here. CM2, we can do up to 8 boilers in a CM2 as well. Vitodens, up to 8 boilers connected on that system. And even CA3s, even though these come pre-wired for the individual boiler, if we add up to 8 modules, so there's 3 in one boiler here, 3 in another, and we got a smaller system here with 2 boilers, 2 controls. We would have to make some adjustments to this particular system. We would have to basically field wire this connection between the boilers. So there'd be some Ethernet cables to long card connections here, maybe changing the position of the inline resistors here. We would also have to adjust basically the lead boiler controls in each one of these back number 4 and number 7 here to now become lag boilers, because there's only going to be one Cascade in this system. As I mentioned, when this boiler comes, out of the package here, number 4 here is actually going to be a lead control Cascade, and we'd have 2 and 3 here. We're now going to reposition these so that basically we have one lead and then we have, 7 lag boilers in this particular system. So it looks a little bit, to be a little bit of work here to set the system up, but it's capable of a very large capacity heating system when we add these CA3B boilers together. As I mentioned, when we started getting into these the communication side and how to wire these communication systems up, there's one boiler, the Viessmann, that has KMK communication capabilities. Important to note that KMK is polarity sensitive, which means that there are positions for these connections where they need to go in and out of the KMK cards. So when we go into a KMK card from another boiler, we go in on 3 and 4. When we're moving from that boiler to either the Cascade or a boiler beside it, we're going to come out on 1 and 2. And you see we're going in on 3 and 4 in the next boiler. And then, of course, out of 1 and 2 up to the Cascade control here. And you'll notice that's a little different plug. That's not a LAN connection. It's a 145 connection. That is the KM bus communication that Viessmann uses to communicate between Viessmann accessories to Viessmann accessories. You'll see the card over here, what it looks like. Same kind of adapter where it plugs into, but now we're using 2-wire, 16 gauge twisted pair, something like that, to do our communication. And where that terminates, so we go from, if we have 8 boilers, we're going to have 8 KMK cards. If we have 6 boilers, we have 6 KMK cards, 1 for each boiler. Once we wire between the boilers, when we go up to the Cascade, we're going to look for some pink plug connections inside the Cascade, which sit directly to the right and below your lawn card we just talked about. And they're sitting over here. There's multiples. There's 2 connections for 145. Just pick one of those. It doesn't matter. As a matter of fact, if both of those are used up and you've got those 2 wires coming from your boiler, you would just slide them into one of those 145 connections that's already done. You can parallel like end switches into those, so they can be used from multiple devices plugging in. Once you power everything up, the Cascade can basically sort through what it needs to identify which controls are which on those little 145 connections. So as long as you've got them connected correctly on 1 and 2 here into that plug, everything on this side should work fine. There is a limited amount of information that the control guys can see with KMK. That gets more into what Mark was talking about back in September there on his presentation. I'm just talking really about how to connect these things together so that we can kind of move through here a little bit. The other area we talked about, when we kind of move away from that standalone device and getting into, external kind of temperature adjustments that are capable on the control, we have, as I mentioned, 0 to 10 volt input modules that are available. So a 0 to 10 volt input module, what it will do is basically allow the board to operate off of a floating set point now. So we've got the current model is called an EA1 module. I just did a presentation on this last week. How about utilizing these EA1 modules and go through all that wiring connections and stuff like that. So if you're interested in these controls, there's a lot you can do with them. And that's, I think that's going to be archived shortly. I think I'm doing another one on March 4th of the EA1 module. So if you're interested in that, stay tuned. The previous generation was called a 0 to 10 volt input module, but effectively they do the same thing. We're talking about 0 to 10 volt. They will take that input from a building management system and they will convert it to a set point. So older controls, you'll see this little box. If the building management system is using 0 to 10, you'll see this little box in close proximity, typically to the Cascade. Looks like this when you open it up. EA1 module connected to the Cascade looks like this. And you'll see the little 0 to 10 volt connection sitting inside of here. When we wire up the input modules, regardless of the generation, they terminate in the same spot. We're going to use that 145 connection. There's a 145 here and a 145 here. And that's going to wire up to that same 145 connection we just talked about with the KMK. So it's a Viessmann device communicating with another Viessmann device on the 145 bus. There's that 144 connection, which is also happens to be the 0 to 10 volt connection. 0 to 10 volt on this one. They are polarity sensitive, so make sure that you've got your connections correct, and they're detailed on the control, which ones are your common, which ones your positive connection. And the 145 plugs into the 145 on the Cascade, and the same with our module over here. The 145 plugs into the 145 on the boiler. So that's completes the connections between the external floating analog signal 0 to 10 and to the Cascade to get that set point. When we also have these connections, which we are looking at for fixed temperature set points, as well as a couple of other options with these. So that same EA1 module, you have the DE1, DE2, DE3 contacts, and this wouldn't be for floating signals. This might be for a fixed temperature. So instead of having that temperature adjust, we close a contact, and it's going to be the same temperature. It doesn't matter if it's January or July that we hit that contact with. We can use the DE1 contacts, are programmable for that. Or on the Cascades, we have the 143, 146. The DE contacts on the modern controls here, the more current ones we use, because our BMS system we can actually pick up that these contacts are closed. You don't necessarily see these contacts as functioning in your bus system. You will see these. We tend to use these more on the modern controls and leave these ones alone, even though they still are available on the more modern controls as well. So if you do use them, the 143 is basically used for, and you'll see them, it doesn't matter what generation control, they're sitting 143, 146 right here on our Cascade. The 143 connection is capable of, if we close a contact, we are going to be able to close the whole system, or basically shut it down or disable it. So we hit that with a Cascade. It's going to basically stop the boilers from firing. Nothing's going to happen there until you open that contact again. So even if you give it a set point, but that contact's closed, nothing is going to happen until you open that contact up. So it essentially just basically grinds the whole thing to a halt when we close that contact on the 143. The 146 could be used for an external demand. So we can basically close that contact here and program into the boiler and a Cascade control what particular temperature we want to have whenever we close the contact. This contact here is always one to look out for after a system's been commissioned. Sometimes they'll use this 146 connection temporarily just to get the heat on, because they're still, wiring up the BMS system. The controls guys are still doing their thing. They're not quite ready to take full control of the system, but they want some heat on in the building. So they'll basically put a little jumper on the 146, set a temperature, and things just happen, heat up, etc. in the system. Problem is the commissioning is done and they forget to take the jumper out. And of course, now the BMS guys are complaining that the system's operating without their set point. So there's some interference there. You open up the control, remove the jumper, and now of course they can, that system is in good operation. So we call that external demand, or that fixed set point temperature. Again, we tend to use the EA1 module connections, the DE1, DE2, DE3, and the more modern systems, because whenever these contacts are closed on those, we can actually see that those inputs are actually doing something. They show up in the diagnosis area of the controls. These don't necessarily show up on in that particular area. When we're connecting to the outside world, so we've talked now about everything internally to the controls here. Now we're moving between basically the BMS system into the Cascade. We're going to have a gateway that basically is essentially is the transmitter here, the one that's basically transmitting information from our system to the outside world. It's essentially looking at that and giving us more information back to tell us what the control needs to do via these little gateways. And we've changed those so that we have the VitaGate 300 is the current one, the top one. The bottom older controls, you might see the Versatronics, whether they're basically put in another box somewhere or they're in their own enclosure, depends on how you'll see those. The setup is the same here, though. We're going to use that long connection. So the long card in the Cascade will be wired directly to these gateways. And how we would do that typically, this is the VitaGate 300 here. We take the long connection from it. with RJ45 or Ethernet cable over to our long connection on our long card in the Cascade, and that basically then the control technician would program that system. I should mention the VideoGate 300 is programmable for whatever type of platform you're using, BACnet or Modbus. When you had the Video Versatronic controls, which are the ones on the right here, same kind of idea. There's a connection in the lawn card here and down to the connection on the Versatronic control on the far right-hand side. The Versatronic controls were specific to whatever platform. So you had to know before you purchased it, well, am I using Modbus or BACnet IP? And of course, you get the appropriate Versatronic control to work off of that. Where you're going to use it as an enclosure, where you're going to snap it on a DIN rail on one of the boilers. It could, again, you had some options there as how you would purchase the Versatronics. Basically, the VideoGate, either you order it in the enclosure or you order it without the enclosure in it. But it's programmable platforms that the control technician would do that basically on site. If you're interested in more information on gateways, Mark, again, it did a presentation here back in November. And it is full of excellent information on the VideoGate 300, specifically how to set those up. He goes through some information, and he even mentions that we've got a basically a simulator that's available that you kind of go through that as well to get comfortable with that control. If you are responsible for setting them up or monitoring them, this little presentation is excellent to give you that information. When we're talking about wiring the system here, so we talked about everything, looking at boilers to Cascade and Cascade to the outside world, and set points and all that stuff, how we wire those. We're talking about pumps and mixing valves and the sensors and stuff like that. We have these massive, excellent drawings that are available for these systems. So whether you are installing this, whether you're troubleshooting it, whether you're the building operator, you're interested in how everything's connected together here and what you've got. If you, again, remember going back to what control am I working with? So you look at the control you're working with. If you use this link that I pasted down here, if you copy and paste that to your web browser, it's going to take you to an area that you'll be able to search that model, and you'll be able to find this particular wiring schematic for that particular control. And again, full of information on where the specific connections need to be for those systems to operate. So whether it's a integrated control as we see here, or the previous one, which is a external control, we've got the same information. Again, you copy and paste this to your web browser, find out what control you're working with there, and you'll be able to find these large documents. And again, they're large enough that even I can read them with my glasses on without having to stand really close to that particular schematic. So it's really orderly, excellent. And in this one here, you can see it's actually integrated. You've got some boiler control stuff on here, low water cutoff, low gas pressure switch, whatever it might be, a damper here for common venting. There's mixing valve adapters. It shows you the whole gamut of how to wire those controls up. And we go back in time here. So it basically just, you click your heels together, go to our website here, then go to historic product information, and you'll be able to get the wiring guide for all the older controls as well. We have those all documented and archived, and very specific on how to wire the mixing valves up for your system, and the pump outputs and where they go and how they're all wired up are included in those documents. So I encourage you to kind of use that stuff. There's no use in trying to guess where those connections go. Use that roadmap. Like I say, the roadmap is always handy if you're trying to get somewhere and you want to get there at the most efficient and effective way. Use the map as a guide. My suggestion here is sometimes it's hard to see the forest for all the trees. You can divide and conquer your Cascade controls, or any controls for that matter, by looking at what the sensor inputs are. They'll go in one location. So the sensors usually plug into the controls, Cascade controls directly. Whereas any line voltage outputs, your pumps and your mixing valves, all that kind of stuff, usually will land on the DIN rail that's connected to the Cascade control, or the boiler control, whatever you might be working with there. In some controls, if we're looking at, for instance, a CM2 boiler that would be wired something like this, that DIN rail might be at the back of the boiler, whereas the actual control is sitting at the front of the boiler. So there'd be some wiring conduit that would go from the front to the back, so that now you've got, of course, all that wiring in the back for your outputs here to your system, and all those inputs on the sensors will be wired to the front of the control. So it depends on what type of controller you're working with and how you're going to kind of attack it. But my advice is sensors, and then of course the line voltage outputs. Do it in a logical order. You'll be successful in your attempts to wire that system up. On the startup of the control, so once we got it all wired up here, we got the connections to the boilers and all the BMS systems set up there, we can go through the programming of the Cascade. Integrated Cascades will have 4 options on the startup. So we got to select the language, the date and time, measuring units, and application. Because it's on the boiler and integrated, you have either a standalone application. So if it's only one boiler, you're going to have standalone. What we're talking about here today is either the application is either going to be a lead boiler cascade control on that unit or a lag boiler control. And this is where you're going to designate that is on the startup. So if you skip it, of course, you're going to have all these boilers basically not communicating. So very important that you make sure you go through this methodically, make those adjustments, and particularly on the application side here, on those integrated controls that are on your CM2s and CA3s, that you select which one's lead and which one's going to be lag. If it's an external cascade control, it knows that it's a cascade control. It doesn't need to be told how it's going to be, how it's going to function. You don't see application. So this would be something like a control connected to a Vitodens or a CU3A boiler, where we're just going to set the language, the date and time, and some units here for whether it's kilowatts or BTUs we want to see on the control. So first thing would be language. You've got some options here of what languages you want to adjust. So North American or French, depending on where we are in North America here. Your date and your time, you just push on the button here, and of course you adjust your date and your time. The date there basically could be day, month, year, or month, date, year. Time here could be a 24-hour or 12-hour clock, depending on whichever way you want to read that. So there's your options here: day, month, year, month, day, year. You select whatever one by pushing it, and then you make the adjustments to the up and down arrow key, push the OK button, and that's your date. Measuring units, we're going to select either BTUs or kilowatts, depending on what we want here, metric or imperial. So we select what we want there and push the OK button at the bottom. And of course, with the integrated controls, it's either going to be single boiler, not what we're talking about here today. What we want to do is go into application, select whether it's the lead, cascade, or lag boiler, and then push the OK button to make those adjustments. So some other adjustments that are going to be prompted. So after you finish that little startup, the control is going to basically log that information, and it's going to ask you, do you want to make any more changes to this particular system that we're operating on here? And you will say yes, and it's going to ask you prompt you for some other information, like how many boilers. Important that the Cascade knows whether it's 2, 3, 8 boilers, what you're looking at. Some of our Cascades, particularly the ones that are working on the non-condensing boilers, like the Vitoron boilers, the older CT3 Vitocrossal 300s, they could operate up to 4 boilers. Some of the old Cascades, the WB2B boilers, 200s, were only 4 boiler Cascades. You couldn't do more than 4. All the modern ones now are up to 8 boilers. So it just depends on what controllers you work with, how many boilers you can actually add on to those. You'll also be asked if it's a common vented system. So a number of our products now can be common vented, multiple boilers on one vent system, typically no more than 4 boilers at a time here. So whether it's a Vitodens, or a Vitocrossal 200 or Vitocrossal 300, as we see here, we have the ability of cascading, and there would be a question whether or not those are they cascaded? Typically, those are the integrated controls, because that's also a boiler control, remember. And of course, if it's a common vent system, there's typically a damper attached to those boilers, and that lead control, even though it's a cascade, still has to operate that damper for that particular unit to function properly. So that's why you're going to get that question on some units. And then whether it's a condensing or non-condensing application really depends on what type of boiler that we're working with there. And the whole idea, just the nuts and bolts of this, if you want to get deeper into this, Mark did a great presentation a couple months back that's archived. But generally speaking, condensing boilers, you tend to see more boilers on at lower modulation rates at any one point in time. Where non-condensing systems, you tend to see less boilers on, and they're always typically at a higher firing rate. So we always just tend to fire non-condensing boilers up to 100%, and then we bring on a second a boiler there and ramp it up to 100%. Versus having the condensing system where we have those boilers ramping up to a particular percentage, and then we have it dropping back, another boiler coming on, and basically we tend to have more boilers on at those lower modulation percentages. Trying to get the system to condense is the kind of the key there. When we're programming the boilers as far in the system there, or in our Cascade in this particular application, we got to get into some of those. We don't have that wizard to start up. We have to go into coding level 2 to do the settings, those number of boilers and participant numbers, all that kind of stuff. Instead of a wizard prompting us on the older controls, we have to get into coding levels to properly make those adjustments. And coding level 2 is accessed by pushing the faucet and the faucet and faucet rad button here that are highlighted. And you get into coding 2 here, and now you'll scroll to the different addresses that need to be adjusted, and you'll go ahead and make those adjustments. To get to coding level 2 on the older Viessmann 300 control, it looks like this. Same idea. Getting to service level, we push the OK and the menu key. Once that control is changed into the service screen here, we got coding level 1 showing up here. We want to get to coding level 2. We can basically flip one finger up to the back key here, and the other finger on the OK button, hold these two down, and we'll get into coding level 2. And again, scroll to those areas, number of boilers, and all that kind of stuff to set those systems up. And on the boiler controls, so we're looking at the individual boilers, we still have some system programming to do on the boilers as well. Things like how many, what boiler number are you? So each boiler is going to have its own designated number. And then sometimes we also have a participant number. So if anything's connected lawn, you're going to have a boiler number as well as that lawn number to work with. On the standalone control, or basically on the modern boiler control you see up here on the top right, we're going to hold down the OK and the menu key. That screen's going to shift into the service menu here. We're going to scroll down using the down arrow key to service functions. We're going to push the OK button there to get into service functions. We're going to scroll down to multi-boiler system, and we're going to push the OK button there, and it's going to basically ask us if we want to go to multi-boiler. You're going to select yes, and the control is going to shut down. It's going to reload as a multi-boiler control instead of the standalone control, and the screen looks like this here, only the boiler number here will now need to be adjusted. Each boiler will have its own special number. So you don't see 2 number 1s or 2 number 8s. It'll always be 1, 2, 3, 4, 5, 6, up to 8 boilers in that particular Cascade. On the other 3 controls we see here, we are going to program a couple extra adjustments on these ones. We're going to go review those as well here. When we're setting up the lag controls on the boilers that have this particular control on them, remember, when we go into the control, it's going to go through a little setup wizard. And instead of selecting lead boiler Cascade, on these guys here on the left-hand side, we're going to select lag boiler, and then it's going to ask us what number it's going to be and all that stuff. So this one here, you get a wizard to set them up. So they're pretty straightforward. These guys need a little bit more extra attention. So we're going to go through this, I guess. So basically, we push the menu key on both of these. We go through the service, and then from service, we're going to basically type in our password. So on this control, it's VI service. On this control down here, it's VI expert. And from here, we can go down to basically system configuration. We go into, it's only really on the boiler side, we can just set up on level 1 here. And we go through general, the subscriber number, what lawn number we need. Boiler is the number of boilers, which number it's going to be. And we can set it up that way as well. It's pretty straightforward. These extra controls, as I mentioned, we've got the OK and the menu key here on this fella. We hold it down. Same with the boiler control we see down here, the GC1B. On these controls, we're going to push the standby and the faucet button here to get into coding level 1. So again, remember, OK and menu, you're going to get into a service level, and coding level 1 will be right there. On this one, we push these 2 buttons, hold them down, and coding level 1 will show up on the control screen. And we basically have two addresses with two of the controls that were on the right-hand side. We're going to tell it that what number it is in the boiler group, and in the general group, we're going to program in the subscriber number or participant number, and they should be the same. That just makes consistency. Where if number one boiler and participant number one are the same, that means that when the control Cascade is calling on number one boiler to fire, it's actually number one boiler that actually fires, not another one in the system. In some controls, you're going to, the ones that were on the left-hand side, the white control interfaces, you're also going to have to program in this, in general, this address 01, you're going to need to change it to a value of 2 and then push OK button. That initiates that communication between that boiler and the Cascade by making this specific adjustment. So 3 addresses, pretty quick for you to basically program. Now, if you have a heating curve you need to set up, so you're doing the standalone function here where we're using the outdoor reset function on the Cascade. Some things you need to know, basically your design day. So, you know, where is the boiler, where's that building being utilized, where's it built, type of heat emitters that we're using, so general information, what type of construction that building is it a circa 1850 or is it circa 2020, what type of building construction was used, and of course what's the function of the building, what are the needs of the occupants and their comfort, all that stuff. I'm not going to get into deep on this particular area. Again, using multiple boiler controls in archive presentation. I did a presentation back in October on application of piping for condensing boilers. It talks in depth about outdoor reset controls. Jody Samuel down in our US, he presented one here, just fundamentals and application of outdoor reset. So some deep dives into what these outdoor reset controls do, what they're used for, how you can manipulate them, and understand better what their functionality is. They are pretty strong as far as a heating curve goes, as far as what I've seen out there. The typical setup here is your slope. So the angle of the heating curve that we're selecting here is the slope. Is it steep because we got a fairly dramatic adjustment of the supply water temperature as it gets hotter or colder outside, or is it flattened out because we don't need to have that big adjustment? It depends on the heat emitters that we're going to be using. But you also have the shift adjustment, which catches some people off guard. What's the shift do? Basically, there's a good comparison down here. If you look at that's your slope. And of course, look at the shift here. This is one example where you see that the slope is adjusted to 1.4 on both of these pictures. But in this one, we've added a 10K shift. So 10K, 10 Kelvin, or 10 degrees Celsius shift. So you see 20 degrees C with a 10K shift. Now at 20 degree outdoor temperature, we're going to target 30 degrees C instead of 20. At 10 degrees, we're at 37 C set point. Now we're at 47. So basically, the shift just parallelly moves that curve up the increments that you change it to. So all these are now 10 degrees higher. Of course, those aren't just the 5 temperatures. They're just reference temperatures of the whole heating curve. We can modulate to any temperature between 20 C and basically 75 C in this curve, depending on the outdoor temperature that we're working with here. So accessing the heating curves for your system. On the modern controls, you press the menu key, and of course you scroll down now to your main menu. You go to heating. From heating, we go over to heating circuits. So remember, if you've got 3 different temperatures, you could have 3 heating circuits. You have to set up the heating curves for all 3 of these. So we'll set up heating circuit 1's heating curve right now. So you press the button, and then of course we got the heating curve over here. We press that, and then we have the ability of adjusting the slope and the shift here to what we're looking for. Use the plus and minus buttons to make those adjustments. Once you're happy with what you've got here, you push the OK button. And of course, now that's basically set. And now you can go back and now go to heating circuit 2, heating circuit 3, and just repeat that for those circuits that you have in your system. The other value that influences your building supply temperature, basically the outdoor reset function, is this room temperature. It's a nominal value on our controls, which means that there is really no feedback of what that actual room temperature is, but it gives the control some sort of idea of what what type of supply temperature it needs to send out to that system. So we always default to 20 degrees or 68 Fahrenheit on our heating curves. You can move that up and down on this extra axis here by making the adjustments. It's going to push the curves up or down based on where you want this to go. It's essentially your warm weather shutdown point is related to where this temperature is. There's some programmability in that warm weather shutdown that you can utilize here. But again, it's a third function of the outdoor reset that you need to be paying attention to on that particular system. So we push the little menu key here. Then we, of course, we go into heating. And of course, whatever heating circuit we're looking at here, we'll look at heating circuit 2 this time. And you've got two functions. You get the room temperature here, and there's a reduced room temperature. And basically, if you use a time program where we're going from normal operating temperatures to setback temperatures, you might have two different temperatures based on your time program that you're going to utilize here. So we select that, we adjust them up and down, press the check mark, and now that's your room temperature we're looking for. So set reduced temperature, as I mentioned. If you've got 3 different heating curves, we're going to have 3 different room temperatures possibly. That's potential. They might all be the same. Heating curves will probably be different. As far as the time programs, when you're using your heating curves that are built into the controls, each one of those heating circuits will have its own individual time program that you need to be aware of. Typically set to 24 hours, so it doesn't interfere with your system. If you want to adjust that, we would go into the same area here, menu key, down to the heating, select your heating circuit, and then of course the time program now. And you highlight your time program here. We just push on it, and then using the little pencil icon that shows up when you do that, you can now use the up and down arrow keys, make your adjustments here, and then basically once you make your adjustments to whatever you're looking for, you press the little check mark, and now that's your time program. If I want to copy that to all the other days, so I don't really want to take the time to make individual time programs, I just push on that little highlighted square. That allows things to copy and paste. And this little window will come up. I just push on, basically connect or click on whatever days I want to copy this time program to. If I want them all the same, basically I click on them all, I push the check mark, and now all of those times of days have been adjusted for each day of the week to be the same. So that basically everybody now is 24 hours a day for that normal room temperature heating program. When we use a building automation, typically, and in this case, you see that we are controlling nothing here. So if we open up the Cascade in this system, you would basically see power to the Cascade control and the communication between the boilers and the Cascade, and of course the sensor here. You would see no pump outputs, you would see no mixing valve outputs, because the building management system is looking after all of that. We have no operational capacity to open or close that mixing valve. It's all basically controlled by the BMS control over here. What they might do looking at this is either close a contact or give us a 0 to 10. So the 0 to 10, they will basically tell us what they want, and of course it's up to us to basically power those boilers on. Of course, the boilers look after their own to get to that particular set point that they're looking for. When you do this, though, that heating circuit 1 is still part of the Cascade logic, and it's possible to turn it off. Typically, what we'll do if you want to turn off that outdoor reset function of that heating circuit, that's kind of a built-in logic of the Cascade, we'll go to that room temperature we just looked at, and we'll adjust it to 3 degrees C. So the minimum. We'll take the time program and we'll basically flatline it. And then of course, we'll take the slope and the shift of the heating curve, and we'll drop those down to their minimums. And you'll see that when you do that, the set point now for all the temperatures that we have on the x-axis is 0 degrees C set point for heating. So we've basically functioned out that the outdoor reset function of that HC1. And one final step, some people will either just wire the outdoor sensor, because if you don't wire the sensor to the Cascade, it will basically give you this open sensor fault. They'll either wire the sensor and just basically leave it in the boiler room, or they'll go to this address 97 here, and they'll adjust it to 1, which essentially turns that outdoor sensor off on the control. So that's how we would turn that off, so that we have no influence of our outdoor reset function that's built into our Cascade with the operation of our building. It's all the responsibility now of the BMS control. And we're rounding it up here. Domestic hot water is the last thing we'll touch on, but if we have a sensor connected to the Cascade control, we can operate the domestic hot water in that system. So a couple of things here. When we plug the sensor in, all of a sudden we're going to get the icon that there's a domestic hot water function on the control. If we don't plug the sensor in, we don't see that. You can adjust your temperature set point under control. So to do that, you push that little button. You push the up and down arrow, plus or minus buttons here to increase or decrease that. Push the check mark, and that's now your new set point. Recirc or the time program on our domestic hot water is also similar to the heating circuit time program we just looked at. Typically, with these, you're going to want to make the adjustments on those. And it's the same for the recirc as well. So if we connect a recirc pump, we're going to follow the exact same logic here. When you go into the time program for domestic, you'll see it's one extra step is it's individual or automatic. So if I leave it on automatic, it's going to follow one of the heating circuit time programs. If I want to break it out of its own and have it on its own time program, I select individual. And from there, I can do the exact same thing I did with the other controls. So basically, I go into the time program here. I highlight the day that I'm looking for. I make the adjustments up and down. I can copy and paste those, or I can make all those days a little bit different. So it depends on how I want to set that little control up. On the recirc, it's basically the same kind of idea where I can look at the program and make the adjustments here as well. So we kind of went through the heating timer program for the heating circuits. The domestic is essentially the same kind of concept. So once you get in there, just that one extra step of adjusting it to individual and then making your corrections as we go there. So I hope you found the information that we looked at here of some value. It does go back in time a little bit, so I find it would be useful for existing systems or even new systems. So it gives you some flexibility there. Feel free if you've got, like as I mentioned earlier, if you've got people that are looking at these systems and they don't quite understand what they're looking at, this little 90-minute review or whatever would be very helpful to them moving forward. So just basically, it's going to be archived. And if you find it useful and you want to share that, please feel free to share that with other people that are looking into this. So I hope you found it at least some information that you can use for your systems that you might be looking after, or if you've got some system that you're preparing to set up there. There's some real good information there on just how to set those up and make sure that your boilers and your cascades are communicating correctly together. So that finishes up the presentation. Is there any questions, Mark?
There was one, and I think I answered it. I think the gentleman was referring to the polarity in the wiring of the controls between the communication cards. So the wiring between pins is polarity sensitive, but it doesn't matter what order the cards are in, and whether that's a device between the KM bus cards in the boiler, or whether it's the communication between the individual boilers. The wiring pins, the wires that are to each terminal is polarity sensitive, but they're not in any specific order between devices.
Well said. Yeah, it's basically as long as the connections are correct, it doesn't really matter what order you wired the boilers in. It basically just makes sure that they're all daisy chain and everybody's communicating together there. So a little bit more, I guess, on the KMK than the lawn on that side, but yeah, it's a good question to ask.
Even with the lawn, though, I mean, I do get questions occasionally because in previous generations of using RJ45 connectors, manufacturers like us and others wanted you to use what they call a crossover cable, so that in one end it was wired one way and the other end it was wired the opposite way. And you don't need to do that with these controls. They're just straight through cables. So any standard network cable works.
Or works just fine. Well, if there's no other questions, we've got some presentations coming up. I think we got an EA1 module one coming up March 4th. I think is it tomorrow or Thursday? I think Jay down in the US has a VitoLens 100. I think it's a F4 fault one. I think he's dealing with or something there. So if you're looking at 100 boilers, I think I might take that one in myself. That would be a good one to have a look at. But We've also been involved in a little bit of training actually this morning before we even started this one up on some interesting stuff moving forward. So we're planning some more presentations that aren't on the schedule for the months kind of after March, April there. So if you're interested in more training, just keep checking back on our website or where the Orange app, wherever you might be finding out where these presentations are being held and what time. There will be more dates added as we keep plugging along through here. So some interesting topics still to come, but there'll be some more stuff added as we move through.
Yeah,
so my tongue's healed. I
good
feel
for you.
better today. Yeah. Yeah.
Tomorrow is VitaDen's 100 product overview, and then Thursday is the F4.
Okay. Excellent. Okay, there is one tomorrow. Is that Jay doing both of those?
Not you.
Not me. That's good.
You can relax. We
There
didn't
you
say
go.
that much by the side. I think it's Jay. Yeah.
Okay.
I think he's doing both tomorrow and Thursday.
Wow. He's gonna have a very hoarse voice on Friday.
That's right.
Yeah.
Maybe we'll let him take Friday off.
Yeah, take it off with Paige. It's no worries.
And if anybody asked, Scott and I said it was okay.
Yeah, no problems. Yeah, we got you. We got you, dude. Well, if there's no questions, we'll sign off. Thank you guys again for attending. We look forward to putting these things out. We just have a good time putting this information out for you guys. And like I say, we just if you guys keep joining us, we'll keep putting this stuff out there. So the more people participating, the better, we think. And of course, this stuff is always available to you after we sign off. When Mark, with his schedule, when he has time to get these videos posted up there, they'll be available to you 24 hours a day, 7 days a week, as long as you get a connection.
Yeah.
So thank you so much.
Okay. Thanks, guys.
Have a good day. Bye-bye.
Bye.